Hello, Dr. Popyack, and welcome to Computer Science Chats. How are you?
Oh, I'm doing terrific. Yourself?
I'm good, thank you. So first, could you please introduce yourself and your educational background?
Sure. I'm Jeffrey Popyack from Drexel University. I'm a professor of computer science. I studied mathematics at George Mason University back in the 70s. And I also then went to University of Virginia for my master's and PhD in applied mathematics. The applied mathematics was in the Department of Mathematics and Computer Science, and it was actually applied mathematics and computer science. And what I was doing was sort of right in the middle with numerical analysis and operations research. So.
Thank you. So what is it that inspired you to pursue computing as a career?
Well, it was a pretty fascinating thing. Computers were new and getting more and more renown, and yet we're only talking about really big mainframe type computers at the time, and what they were capable of doing was ridiculously small compared to what they're capable of today, but it was still allowing people to do things that just weren't imaginable. And so I was a mathematician, and I was really interested in learning more about computers. And I guess I was fortunate enough to have a series of jobs with the federal government, with the Naval Air Systems Command back in the just all while I was in college, every summer, and also a few weeks in the winter, even up until after I graduated. So with 5 years of that, I got to work in an engineering division for a few years and was mostly doing programming, and that really helped me sharpen what I was interested in.
That's very interesting. How would you describe computer science or computing fields in general?
I like to think of computer science as sort of the science of solving problems using a computer. And I guess in the days when I was learning it, the types of problems that were being solved were the big mathematics, physics, engineering type problems that had systems of equations, linear and nonlinear equations, and you needed to find an answer that wasn't going to be in a closed form solution like you could solve with a calculus transformation, and you would need to get numerical results. And so then being able to get those as close to the actual answer, knowing that what you would have would be an approximation within the physical limits of the, I guess, precision of the machine you were using. And that's what the numerical analysis field was. So that was my introduction, at least to computing. But I've seen then, just as grown more and more in all of these different directions, that it's always about solving problems of some kind, whether it's just with words or with logic, with graphics, any of those things. I tell my students that a computer program is like the ultimate word problem in math. And so where you define your variables and you model some equations and you come up with a solution, a method, and then once you get your answers, you have to find a way of interpreting and reporting those.
Thank you. Could you describe some of the activities that you do through your work?
Yes. Well, these days, what I'm teaching is mostly the artificial intelligence classes at the upper level undergraduate, and the computer science principles for the non-majors in our college. I was fortunate enough to be a member of the CS principals team the last few years before the AP CS principles launched, and that was pretty exciting. A lot of the work I'm doing these days, we have a program called Jumpstarting Philadelphia, CS for All, and we're working with the School District of Philadelphia to help, I guess, get teachers prepared for being able to get certified to teach computer science and to teach computer science principles and perhaps APCS principles or APCSA and other types of programming or computing classes. And so there's a lot of people out there. There's a lot of schools, and there really aren't that many where teachers are teaching computer science or even trained in that. So we're spending a lot of time with that, and it's been pretty fun.
Yeah. So what do you like most and what do you find most challenging about these activities?
It's, well, Philadelphia, you're in New York, right? So you know what a big city is like. Like, maybe I don't know what a big city is like, but I know what Philly's like. And it's just really hard when you have so many moving parts to try to get everybody moving in the same direction. And we've been very fortunate to work with people in the school district who are also committed to doing this and can help us uh, work with the teachers and find them and encourage them to be able to do this. So that's been pretty good. And we're seeing teachers are getting certified now. And we have we've started an awards program with the CS for Philly, which is a local group that has really been one of the instigators in this whole area. And it's great to be able to work with all these folks that have that same sort of mission in mind. And so that's pretty good. Also, I guess with some of the other activities that I do on the job, artificial intelligence is always fascinating for me. I guess always has been. So I'm pleased to be able to teach that too.
Thank you. What advice would you have for high school students who would like to get into this field?
Well, I guess in order to get into it, these days, you don't necessarily have to know how to program a computer in order to be able to do some computer science. And that was a real difference from when I was learning, and even for quite some time beyond that. Pretty much any computer program you wanted to use was something you had to write. And so the only way of learning computer science was to take a programming class and continue working your way up from there. But these days, AP, CS principles, and courses like that are a great way to introduce what the possibilities are of computing and the notions of computational thinking, and can sort of gradually and more gently introduce you to programming concepts and ideas. So I would definitely recommend you check out a CS principles class, and recommend those to your friends too. The next thing, I guess, mathematics is important. It isn't necessarily, and this is like coming from a mathematician too, who had to take a lot of calculus, advanced calculus, and so on. And calculus is important, but it isn't necessarily the only type of mathematics that's out there, and not necessarily the stuff that you'll find most relevant for a lot of the computing that you're doing these days. So classes in statistics, I think, are really important and will be continuing to be more important as we move forward. So I would recommend that. If you like computing, if you like programming, find a project and then devote yourself to it. And then I guess once you get into college, and if you want to major in computer science, that's terrific. If you want to major in something else, that's terrific too. I'd recommend looking at a minor in computer science. And if you're majoring in computer science, I would recommend that you look at a minor in some field, something you're really interested in. So the reason being that computing is needed everywhere these days. And so it's not necessarily you're just going to be somebody locked in, stuck to a terminal and doing nothing but code your entire life. It's the ability to apply those computational thinking skills and problem solving skills to real world problems in any line of work. I guess so. Yeah. All right. So that'll be enough.
That's very interesting. Where do you think that computing is going to go in the future?
Well, I guess I hinted at that somewhere. I think that you'll just see it everywhere. And so that doesn't narrow things down too much. But if you take a look at what some of the big problems are that we're dealing with these days in terms of energy consumption and even stuff like trash. I mean, recycling is really important. It turns out that very little of the things that get recycled actually ever really get recycled. They go into a recycle bin and then they eventually end up in the trash because it's not all that easy to recycle discarded items. And so being able to apply some knowledge to areas like that and be able to help automate and solve problems that can make use of this tremendous power of computing is a really good thing. So look at what the big problems are in society. I also think artificial intelligence has continued to get important. There was a study, I think probably about 3 years ago now, from the Brookings Institute that just laid out what they think the future of artificial intelligence is, and in terms of what is the impact it's going to have on the workforce. And one of the impacts, I guess people are very worried that jobs are going to disappear because as more and more things can be done by computers. And it turns out that some of the lower level jobs that don't have a lot of variety in them are easier to automate than some of the other ones that are more skilled positions. And so it's important to, I think, be flexible as you're moving forward there.
Thank you. And this also leads into my last question. Where do you think that computing education is going to go in the future?
That's an interesting question, because when I was learning computer science, it was mostly taught in mathematics departments, sometimes in electrical or computer engineering departments, and sometimes in schools of business, but predominantly in math departments. And I guess as time went by, more and more students were taking computing, more and more faculty were computer science, and eventually CS ended up splitting off and becoming its own department at most universities. But we've seen that field has continued to expand. We have software engineering, and now data science is really big, and information technology, information systems. There's just so many areas, digital media, that have some sort of a computing aspect to them. I like to tell people that I think that computer science is pretty much what engineering was in the previous century. I think probably in the early 1900s, if you were majoring in engineering, you mostly took the same courses. There weren't as many specialties. Electrical engineering obviously got to be very big, chemical engineering, mechanical engineering, but certainly aerospace engineering wasn't around then, some of the others. And these days, if you are an engineering major, you will find that you are an engineer first, and then your specialty within the field next. And I think the way I see things going, that it will be the same way with computer science. And so you'll be a computer scientist first, but you might have a specialty in artificial intelligence or computer graphics, computer interaction. There's a lot of different specialties now, but they're all sort of tied together with computing the way engineering and its fields are.
Thank you very much for meeting with me and for being willing to do this interview.
Oh, golly, it's my pleasure. People want to know what I think. It's usually they can't shut me up. So it was nice to be able to be here and talk with you today.
Thank you.